Hi students, welcome to Veteach app. In this video, I will explain about the Millman's theorem. Millman is a person who given this theorem, that's why we are saying as a Millman's theorem. Okay, in this theorem, we have n number of sources, voltage sources in series with the resistance and connected in parallel. So all our networks are connected in parallel. All our networks or transformers connected in parallel. So each and every parallel network is consisting of some source and as well as some internal resistance. That is information given in this Millman's theorem. Okay, in Millman's theorem what happens here? V1, V2, V3 up to Vn are the voltages or generators across in series with the resistance R1, R2, R3. How these are? These are in parallel connection. So instead of all these resistance, make it into one equivalent circuit diagram, that is V in series with the R across the low resistance. R and RL are in parallel. Right? Now, students, R is the resistance. Reciprocal of R, 1 by R is equal to nothing but what? It is a conductance G. Isn't it? Why? Resistance are in parallel, means 1 by R1 plus 1 by R2 plus 1 by R3, like that going on. Instead of 1 by R1, what we can write here? We can write just G1 into V1 plus G2 into V2. Right? V1, G1, V2, G2, go on. So what Millman given that to find the voltage, total voltage, okay, algebraic sum of the voltages and as well as the resistance by the resistance values. Drop with respect of the resistance. V1, G1 is a drop, voltage drop, like that. So R is equal to 1 by G or G is equal to 1 by R, that we can write here. So Millman's given information V is equal to V1 into G1 plus V2 into G2 by G1 plus G2 plus G3. This is the basic concept of Millman's theorem. Right? So here see V1, G1, but G1 is equal to 1 by R1. And this is current source here, I2. So in parallel we will discuss about the current source and in series we will discuss about the voltage. So that voltages are converting into a current source. Voltage source converting into a current source IS. So here I1 is equal to, means Z is equal to or V is equal to I into Z, or Z is equal to V by I. What do you mean by Z? Z is a impedance value. When we are discussing voltage, we will discuss about the impedance. In the same way, if you go for a current, that is Y. Y is reciprocal of impedance, right? Or Z is equal to V by I na. So V is equal to I into Z. But reciprocal of Z is equal to Vi by Y. Why? Because Z is equal to 1 by Y. Okay. In series, we discuss about the impedance Z value. In parallel, we discuss about the admittance value Y. So then V is equal to I by Y or I is equal to V into Y. So current and as well as the voltage. Voltage, resistance, current, admittance. Current, parallel connection and voltage, series connection. Current, parallel and voltage, series. So here the equivalent circuit diagram, current in parallel with the resistance across the load resistance. Okay, current in parallel with the resistance across the low resistance. Now current division method, I is equal to I1 plus I2 plus I3, already we know. Then G is equal to G1 plus G2 plus G3. Then according to Millman's, what happens here? I is equal to I1 into R1 plus I2 into R2 by R1 plus R2 plus R3. Before what we discussed, where we discussed there G1 into V1. Here I and as well as the R. Why? Because it is a parallel connection. In parallel connection, we discuss about the current. Okay, so this is G is equal to 1 by R or 1 by T is equal to 1 by R1 plus R2. So G and I plays a major role in Millman's theorem, or voltage and as well as the G plays a major role. It may be a series, it may be a parallel. Okay, so at last the equivalent circuit diagram, voltage in series with the resistance across the load resistance. Here we have to find the load current IL. If you observe this, what you are understanding, what you are getting, or you are remembering, that is equivalent circuit diagram of a Thevenin's theorem. Thevenin's theorem, right? So we'll do one problem here. So find the current through millimens. Here voltages are there. How many voltages are there? 1, 2, 3 or voltages are there. How these terminals are? Plus and minus. Actually what we'll keep minus and plus. Here what happens here? Reverse. Means the value will be in terms of negative. Means fall in voltage. We'll say as a fall in voltage. Okay. R1, R2, R3. The three values are same. R1, R2, R3. Three values are same. But what about the voltage here? 4, 2. Here what happens? It interchanged here. This is rise in voltage and these are in fall in voltages. So these two have to make plus and we have to, from this we have to make a minus. Now G is equal to G1 plus G2 plus G3, where G is equal to what we can get here? 1 by R. So 1 by 4 plus 1 by 4 plus 1 by 4. If we take LCM, we will get 3 by 4 here. Then R is equal to 1 by G or 4 by 3. Now what is the formula we have? V is equal to V1 into G1 plus V2 into G2 plus V3 into G3 by G1 plus G2 plus G3. What V1 we have? Here's a minus. I said now, why minus? Because it is fall in voltage. Here plus, it is rise in voltage. So minus 4 G value, minus 2 G2 value, 10 G3 value by G value. So how much you got here? V is equal to 4 by 3. So given a circuit becomes here total voltage, total resistance across the load resistance. From that we can find the load current IL. According to the Thevenin's theorem, IL is equal to V by R plus RL. So how much current is there? 117.6 milliamps. N number of generators are there, make it into only one equivalent circuit diagram. If it is series or parallel, then you have to find the G or R as well as the R, or I or as well as the V, and make it into a minimized, a reduced circuit diagram. So this is the basic concept of Millman's theorem. Okay students, thank you.